Okay guys, back to it again, and we are now moving on to some of the basics of Python. And obviously, since it's a 100-day challenge, I will do my best to drag this out as long as I can, which is which means I basically have to, you know, which basically also means I have a lot of time to study the language deeply and extensively. I have 100 videos to cover, 100 topics to cover, which gives me, you can say, the freedom to make my videos short and to torture you guys less and myself. And we can start with the first most basic thing, which is like, a simple variable. So the book that I'm following, which I mentioned in the last video, Python Data Structures and Algorithms, it has a very good statement that I liked, that said variables are labels attached to objects, they're not the object itself. Which means that everything that any sort of variable that you will create in this will sort of just point to that object. It is not actually that object, which is also something different, because if you remember, in other languages, whatever was assigned to a variable stayed in that variable. It did not just point to that variable stored it. So what does this mean? That something is not being stored, it's just being pointed at. So for example, if we take, and the best part, you don't have to give a type. For example, if I make a small array or list of any sort of objects, 1 2 3 4, let's consider this. And if I ask to print, it will obviously print that. There you go, that it was that easy. And now let us see, if we add something different to the list, what happens, if we don't use our normal naming conventions for an array. Let's say, let's see what happens now if I try to get print. So you see, it did not give me any sort of error. It did not treat it as a strictly sort type of array. It did not say that, this is just an array, you cannot write anything else here. Or it did not say, okay, you're limited to integers, where why is there a string in this? It's treating it as an object, which means that any variable, you can store data in this form. You don't have to go through the classic old naming conventions where you give an integer data type and then you restrict that whole list to an integer data type, which means you can basically mix data of all types. And I think we can do the same with strings as well. If I add something, no, if I add something, sorry, float, will it print that? Let us see. Yes, it will. So this is something very interesting to read, that it does not really care whatever you put into it. It will just treat it as an object, which means it's at the back end. Obviously for us it's easier, but at the back end it's saving a lot of space. You don't have to create different, you don't have to allocate memory to one specific thing. You do not have to put it through the torture of being restricted to only one data type, which is something good. And with that being said, I think we come to the not the end. I forgot there is something else we have to do. We have to check the type, obviously. We have to see what is the type of this data that I have stored in this object. See, it's giving me a list. And if I just remove this data, if I just give it floating point data, it should give me something 1.0, 10.3, 2.4. It should give me something different. Okay, it's still giving me a list for some reason. If we try it in a new section, 10.3, 4.3. Okay, for the sake of making it something different, we will treat it as something different. Okay, it's still giving me a list. If I just restrict it to integer type data, what does it say now? Okay, it is still giving me a list for some reason, although in the book it should tell you it's an integer. But if we try to, if we go through this whole process where we say b is equals to a, and then we append something to a, for example I'm gonna append 5, and now if I print b 1 2 3 4, and if I ask it to give me the type of b now, what does it give me? Okay, it will still give me a list. So this is something that is, I don't know why it's happening, but it is supposed to give me C. So I think the concept of this whole thing is how it treats everything as a list, as an object, and not as, you know, an integer, not as an array or not as a string, you know. I think there is obviously the string class that we use, but it is not necessarily limited to such naming conventions, which I find very nice. For the sake of not being embarrassed on camera, I tried to make a different sort of, you can say, integer list, and I tried to get it, but it's giving me the same thing. It's giving me a list. So I guess the concept that we can absorb from this entire video is that variables are treated as lists, as objects, and variables are not necessary. They do not necessarily. They're not necessarily the objects themselves. They're just labels for the objects. They point to those objects. And yeah, that's it for today's video, for this video, and we'll be continuing more in the next video. Thank you and bye. For the sake of not being embarrassed on camera, I tried to make a different sort of, you can say, integer list, and I tried to get it, but it's giving me the same thing. It's giving me a list. So I guess the concept that we can absorb from this entire video is that variables are treated as lists, as objects, and variables are not necessary. They're not necessarily the objects themselves. They're just labels for the objects. They point to those objects. And yeah, that's it for today's video, for this video, and we'll be continuing more in the next video. Thank you and bye.